Have a good day. This is Madeline Japolik, BS82A. Welcome to OC Network Layer in Chapter 5. In computer science, the concept of network layers is a framework that helps understand complex network interactions. And there are two models that are widely referenced today, the OSI and TCP or IP. The concepts are similar, but the layers themselves differ between the two models. So while TCP/IP is the newer model, so the Open System Interconnection OC model is still referenced a lot to describe network layers. So the OC model was developed by the International Organization for the Standardization. And there are 7 layers. So physical layer, the example here is cable or the RJ45 cable. Data link, so which is MAC for switches. Network for IP, so these were the routers. And transport, which is TCP, UDP, and the port numbers. Session, sync and EC key. Ang presentation, which is encryption, ESC2, PNG, MIDI. Then application is NMP, HTTP, and FTP. So people have come up with tons of mnemonic devices to memorize the OC network layers. One popular mnemonic starting with layer 7. So is all people seem to need data processing, but one that I'm partial to which start with layer 1, so is to the TCP/IP model is a more concise framework with only 4 layers. So network access or link, so internet, transport, or host to host, the application or process. The network layers and function. For the OC model, let's start at the top layer and work our way down. So layer 4, also called the process layer. This layer combines the OC models or layer 5, layer 6, layer 7. So how network layers work. So as we walk through an example, keep in mind that the network layers models are not strictly linear. One layer doesn't finish its processes before the next one begins. So rather, they work in tandem. Application for presentation and session layers. So let's suppose you're using the Skype na laptop. You're messaging your friend who's using Skype on their phone from a different network. So Skype as a network connected application uses layer 7 or application protocols like Telnet. If you send your friends a picture of your cat, Skype would be using the file transfer protocol or FTP. Layer 6 presentation, receive application data from layer 7. Translate it into binary. Uncompress it. When you send a message, layer 6 encrypts the data as it leaves your network. Then it decrypts the data when your friend receives it. Application like Skype consists of text file and message files. When you download these files, layer 5 session determines which data packets belong to which files, as well as where these packets go. Layer 5 also maintains and ends communication between devices. So, transport and network layers. or layer 4 transport receive data from layer 5 and segment it. So each segment or data unit has a source and destination port number, as well as a sequence number. The port number ensures that the segment reaches the correct application. The sequence number ensures that the segments arrive in the correct order. So this layer also controls the amount of data transmitted. Like for example, your laptop may be able to handle 100 Mbps, whereas your friend's phone can only process 10 Mbps. So layer 4 can dictate that the server slows down the data transmission, so nothing is lost by the time your friend receives it. But when your friend sends a message back, the server can increase the transmission rate to improve performance. Lastly, layer 4 performs error checking. If a segment of data is missing, so layer 4 will retransmit the segment. So TCP and UDP are both very well-known protocols, and they exist at layer number 4. So TCP favors data quality over speed, whereas UDP favors speed over data quality. Layer 3 network transmit data segments between networks in the form of packets. When you message your friends, this is layer assigns source and destination IP addresses to the data segments. So your IP address is the source, and your friends is the destination. Layer 3 also determines the best paths for data delivery. So data link and physical layers. So layer 2 is the data link. Receive packets from layer 3. Whereas layer 4 perform logical addressing, or the IPv4, IPv6. So layer 2 performs physical addressing. It adds sender and receiver MAC addresses to the data packet to perform data unit called a frame. So layer 2 enables frames to transport it via local media. Example, copper wire, optical fiber, or air. This layer is embedded as software in your computer's network interface card or NIC. In short, layer 2 allows the upper network's layers to access media and controls how data is placed and received from the media. So hardware, the things you can actually physically touch, exist at layer 1, which is physical. This layer converts the binary from the upper layers into signals and transmit them over local media. This can be electrical, light, or radio signals. It depends on the type of media used. When your friend receives that signals, they are decapsulated or translated back into binary and then into application data so your friend can see your message. So the conclusion here is this is a lot observed. Essentially, network layers help us understand how data moves from something human readable to computer readable to transmitted signal back and then. So that's all for this chapter 5 OC network layers. So I hope you learned something from this, and thank you.